Let us continue our discussion on the signal integrity. So in the previous part we have just talked about the term signal integrity. So we were saying the signal integrity could be something which is related to the issues that are caused in the signals. So basically what are those problems? How can they come on a PCB? So let us continue on those terms in this tutorial. So the first thing, let us see what are all the major issues which could lead to signal integrity. So we are going to talk about three important issues here. One is called jitter, one is called overshoot, and the other one is called the undershoot. So we will talk about what is jitter, what is overshoot, and what is undershoot. So jitter is nothing but basically a deviation from a signal with respect to its periodicity. So if you see the image here, there is a signal, a square wave basically, which has 50% duty cycle, which can be seen here. So this signal actually, when you transmit over a channel, so when we say channel is nothing but the path between a driver and the receiver. So when we transmit the signal over receiver, ideally the waveform should be the thicker wave that you see here, which should be received at the receiver. But sometimes due to a problem called jitter, the transition you see here could come either early or late. So why this occurs we will see in later videos. So there is a simple explanation of jitter which could arise in a communication channel. So this jitter could be two ways. One is called a random jitter and second one is called a deterministic jitter. So when we say random jitter, random basically is like which can occur at any point of time and cannot be predicted by the designer. So this could basically be due to the white noise in the boards, whereas the deterministic jitter, so when we say white noise, these are mainly due to the thermal issues that are seen. So when it comes to deterministic jitter is something which can be seen. So example, when we say the deviation has come periodically here, which is seen across the waveform. So deterministic jitter is something which can be predicted, which can be clearly seen that this is a jitter seen at a given intervals. Now what is overshoot? Overshoot is a condition where the signal exceeds beyond its certain level. So if you see here, this is the level which is prescribed as per the digital logic levels, and when we transmit a signal, you can see here it has exceeded a little. So if you see this particular waveform here, a simple trapezoidal kind of waveform we are seeing here. So this is the actual waveform, but you can see the signal has exceeded beyond its high level and gone to certain level. So this condition where the signal exceeds its target is called a overshoot. So overshoot definitely is a very dangerous criteria, because the digital systems are restricted to operate at certain levels. So if we apply a voltage level beyond certain characteristics or its specifications, even the vendor who has submitted that IC may not be able to predict what could happen. So because the characteristics are definitely done, or the IC is characterized as per the specifications provided in the datasheet, any voltage or thermal or anything beyond its characteristics or specifications could cause an issue which is unpredictable basically, because even it's not tested by the vendor itself, right? Now let us come to the next one, which is undershoot. So undershoot is a condition where the signal is lower than its desired value. So now you can see here, this is the actual value which it should be, and now it has gone down to a level. So what you see here basically, the gray value, the middle value is the typical value, and this is the VIH and VIL. So the input high, so this signal you can see here, it has gone down below the desired low level of the tolerant value to the high value. So this is treated as indeterminate value, and what happens is the value could not be read at that instant by the receiver. So it meant undershoot could cause variation in the bits that is read by the receiver, which is definitely not desirable, as we have to have a channel which has all the bits that are being read without any issues. And then all these, the jitter, the overshoot, the undershoot that we talk, all these lead to something called bit error rate. So bit error rate is nothing but the ratio of number of bits that are failed at the receiver to the number of bits that are transmitted. So why we are calling only bits here is because we are talking mainly about the digital signals here, high frequency digital signals. So digital signals are nothing but 0 and 1. We generally talk about bits. So when we transmit bits in the channel from transmitter to the receiver, the bits might get altered, as we talked in the previous slide. Due to undershoot, we have seen that there could be a indeterministic value that might be received by the receiver. So in that case, there can be a failure of the bit. So this particular ratio is very important and is like a important characteristic to determine the sanity of this particular channel. So example, we might have seen in many cases where BER of 10 to the power minus 12 is desired for high speed interface like the Ethernet. So we will talk about that scenarios later. Just this is an example scenario, and if you see the waveform here, this is basically the BER for different data rates and different communication topologies. This is a source from Wikipedia basically. So this is how the bit error rate is calculated, and the lower the bit error rate, the channel is very good for transmission, and there are no issues that are seen here. And now we are talking about the failure scenarios, but why do these failures occur? So we talked about signal integrity as a term, and we said that due to signal integrity these are the issues that can be seen, but why these issues come up? So we have listed some of the important points here. One thing is signal reflection, which could be one of the major problem, and then crosstalk, ground bounce, EMI, and any PDN issues. PDN is power distribution network issues, so which is more related to the power topology of your board. So we will talk about these particular scenarios in the next videos. Hope we are syncing with the flow, and please visit our previous videos to just see what we have talked about, so that the pattern of this training is understood. Please post your questions. Please let us know if you have any issues with this video. Please like our channel. Thank you.